So this project deals with how to improve the performance of humans on baggage screening tasks. So to give you some context, you might be familiar with the fact that across many US airports and checkpoints, there are these machines that are installed to screen your luggage, right? So they're screening your luggage, for example, to detect explosives when you send your luggage to the back of the plane. And these machines are installed to a lesser extent in checkpoints, right, where they're evaluating individual passengers and carry-on luggage as you go through the TSA queue. There's also, to a greater extent, these X-ray machines that are evaluating these images, and what they're looking for is not only explosives, but they're also looking to detect, something like a weapon.
One of the big challenges is to do baggage inspection very accurately, but also very quickly. You can't afford to very carefully analyze each piece of luggage, but of course you can't afford to make mistakes, because that can be really, really bad, right? So what we are trying to do is to improve the process in both directions, make it accurate and make it quick.
So we have been looking at two ways to do that. The first is to develop a new paradigm for screening that not only uses single humans to evaluate these some problematic images, but we're trying to say, well, can the judgments from multiple people be combined to come up with something that is more accurate, more robust? The second way that we're trying to address this challenge is by seeking to understand how to improve training of TSA agents to improve their capabilities to detect shape threats, for example. So we, with the objective that if we understand their weaknesses, then we can target them and we can tailor some training modules to them to, gradually improve their performance over time over difficult images.
One of the things that we're planning is, with the learning you do of the image classification task and the learning you can do of the agents who perform those inspection tasks, we can learn the weakness of agents and design training exercises that will make them improve at those weaknesses. So in general, it will benefit the end result, more accurate and faster inspection, and also it will improve their human agents, the performance of their human agents.
My field of study is industrial engineering. More particularly, I've been working with what we call wisdom of the crowd, which is aggregating human judgments to form a better total judgment, to reduce false negatives, which is how often a bag is labeled as not having something that it shouldn't have in it, while it does, or reducing false positives, which is where they think something is in a bag, they have to open it up and go through it just to find there's nothing in there. Both of those are costly to TSA, as well as kind of annoying for the passengers going through that process. So our idea is trying to use aggregation methods to reduce those while maintaining a higher level of security.
Okay, so my role is actually to come up with the different algorithms that can determine which participant or which worker should be used for each of the baggages, and at the same time try to figure out which method there are different methods through which we can combine the results from the human participant and the machines. My job is actually to figure out which best method is suited to combine these two approaches.
Our group at UTEP, we are mainly working on the machine intelligence part, where we explore the state-of-the-art neural networks, machine learning algorithms. We also develop novel algorithms to help improve the visual screening task. To be specific, we have developed a prototype of a recommender system, and we also have been working on automated image classification task that classifies the images that we generated based on whether the images have unwanted objects or not. And even before that, we generated a synthetic data set of X-ray images because these type of data sets are not publicly available that much. So our first step was to develop X-ray images, synthetic data set for X-ray images.
Well, it's been wonderful to work on this project. It's a very interesting interdisciplinary topic. We're combining an expert in human intelligence from ASU with expertise in artificial intelligence from UTEP, and hopefully the end result will be useful for DHS. We expect that it will.
The long-term goals for this project is kind of like potentially develop this tool to the point where it could be realistically implemented, tried in practice, right, at an airport, or in the long term, we could come up with a system that is kind of a hybrid system that combines machine decision-making with human decision-making. And by combining them, we can get better outcomes, and we can do it at low cost.